All right, this is the solution for question 6, part B. All right. The question says use a right Riemann sum with the four subintervals indicated by the data in the table to approximate the definite integral from 0 to 12 of k of t dt. Indicate units of measure. Is this approximation an overestimate or an underestimate for the value of the definite integral from 0 to 12 of k of t dt? Explain your reasoning. All right, so first of all, right Riemann sum. All right, so remember, we've got the four subintervals, 0 to 3, 3 to 5, 5 to 8, 8 to 12. All right. And remember, a Riemann sum just means rectangles. So we are using the area of the rectangle to estimate the area under the curve. All right, so from 0 to 3, it is 3 units wide times, now remember, we're using a right Riemann sum, so we're using the right-hand value to find the height of the rectangle. So 3 times 5 plus the next width is 2 times the height on the right side, which is 10, plus the next width is 3 from 5 to 8 times the height on the right, which is 20, plus the next one is 4 wide times the height on the right, which is 24. Okay, now, of course, you don't have to simplify this because this is just a numeric value, but you could simplify, and I'm going to show you that. So 15 plus 20 plus 60 plus 4 times 24, 80, 96. All right, and then if you add all of those together, you get 191. All right, now it also says to indicate units of measure. So remember, I'm taking the value of t. So remember, we're taking t, which is in seconds, right? And I am multiplying by the value of k of t, which is in feet per second, right? And so the seconds would reduce, leaving us with an amount of feet. So feet is the unit. All right, now it also says, is this approximation an overestimate or an underestimate for the value of k of t? All right, so what were you told? Okay, up at the beginning, you were told that k is differentiable and increasing. So let's say that I have a graph of a function that is increasing, right? So something like that. Right now, if I use a right Riemann sum to estimate the area under the curve and it's increasing, I am going to get an overestimate because you notice how these areas are going to be above the curve. And so you would say that this estimate is an overestimate because k of t is increasing. All right, so that is part B.